Hey again, class. I just want to do a few more examples of how to do these binomial random variable questions. Specifically, I'm going to be doing question 4 from review exercise 2.3, working with binomial distributions on page 85, right here. So yeah, the idea is we're always trying to look at these questions and say, is this a binomial experiment? So that's the first thing we need to check. So when I look at this question, I see I'm shaking hands with 8 different people, and when I shake hands, 1 in 20 people have influenza. So there's a good chance that if I shake hands with those people, I'm probably going to catch the flu. So it's kind of like a binomial experiment in that, well, for one, we have 8 trials. And remember, with a binomial experiment, we have those 4 criterion. 2, well, really, the number of people with influenza, it's the chance of getting influenza is not really going to change from person to person. So we have independence. Oh, I think my page just turned a bit. Okay, so we're independent. 3. So for number 3, so a success, and this isn't really a success, but this is get the flu. But for the purposes of this experiment, it's a success. And failure is we don't. Okay, and 4, the probability of success shouldn't change, right? So the probability of a success should be equal to 1 in 20, or 0.5%, and then a probability of failure should be equal to 19 in 20. Right, so this is 0.05 or 5%, and 19 to 20, that's 0.95. Okay, so the probability that none had the flu. Now, to model this, because we know it's a binomial experiment, because it meets these 4 criterion, we can use the formula to figure out the probability of a binomial random variable. So the probability that none had the flu. So the probability that none of the people that I shook hands with had the flu, so I didn't catch it. So this is the probability that x equals 0. So remember, we have, in this case, we're going to have n equals 8. Okay, and the probability p of success is equal to 0.05, and the probability q of failure is 0.95. So this is going to be 8, choose 0, 0.05 to the power of, what is it here, to the power of 0, and 0.95 to the power of 8 minus 0. So in other words, this is going to be, 8 choose 0, it's going to be 1. Anything to the power of 0 is just 1. And then we have 0.95 to the power of 8. And what's that going to be? I have my computer open behind me, so I'm just figured it out on there to help myself out. What did we get? This should be 0.6634. And with probabilities, you usually don't need to go much past 4 decimal places, although it can help in the intermediate steps. So maybe 204. Let's include as many decimal places as possible till the very end. So at the very end, I get 0.6634. Okay, or in other words, 66.34% chance that none of the people I shook hands with had the flu. Okay. B, the probability that 1 had the flu. This is I'm just taking this right from the question sheet on page 86, or 85 rather. So it's the probability that x equals 1. And this is 8 choose 1, 0.05 to the power of, well, now x is 1, so I'm going to change that to a 1 right there, and 0.95. This is 8 minus 1. So this is equal to 8 in here, 0.05, and then I don't quite know what 0.95 to the power of 7 is, but when you work it all out, what you're going to get is, this is equal to 0.279335, just including lots of decimal places until the end. Okay, or in other words, it's approximately 27.93%. Now, last but not least, C, this is saying at least 7 had the flu. Now, this sounds pretty challenging on the surface because, well, let's see here in just a second. So the probability that x is at least 7. Okay, well, yeah, so this is the probability. So the probability that x is equal to 8, because, you know, what does it mean to be the probability, what does it mean to be at least 7? Well, it means that either 7 of the people you shook hands with had the flu, or 8 of the people you shook hands with had the flu. So the probability that 8 had the flu, and the probability that 7 had the flu. And you add those together, and that'll give you your answer, right? So you can actually compute it individually. So this is 8, choose 8, and we just plug this formula in, 0.05 to the power of 8, and 0.95 to the power of 0, plus 8, choose 7, 0.05 to the power of 7, and then 0.95 to the power of 8 minus 1. Just going to figure some of these out on my handy calculator. So they say this one here, the probability of getting 8 successes is incredibly tiny. So it's basically 0. When I rounded it up, it equaled 0. Plus, now let's say the probability we get 7 successes, same thing. It's kind of unexciting when you get a 0, but that's okay. When I round these off, I get 0. So in the end, I get a big fat 0 right there, because 0 plus 0 is equal to 0. But the point that I wanted to make here was that each of these individually, when you're trying to figure out when this is a inequality as opposed to an equality, you simply add up the ones you need to compute. Okay. So I hope that helps you out a little bit. It's going to be pretty relevant on this assignment. I know there's only a day or two left to complete it, but I'm hoping this gives you some background and helps you out a little bit with it. So yeah, if there's any questions, feel free to leave a comment or to message me. I'll try my best to help you out. Thank you. Have a good night.